All right. It seems a little pretentious to model a talk after William James, which if you're familiar with his writings, you might catch the connection. But a little over a year ago, I spoke at Arizona State, and I had in my talk Aristophanes and Plato. And as I circulated around the campus, a philosophy professor just noticed the title and asked if I would come talk to him. And it was such an invigorating discussion I had with him about scientific discovery that I think it's a useful hook to try to get more people involved. And so, looking at how William James can help us think about imaging informatics. Just a little bit of a disclaimer that I am, far from an expert in the domain, and one of my purposes in organizing this was to learn a lot more, and so I was glad that I could find as eminent authority as Alfred North Whitehead to say that what I really should be doing is demonstrating that I'm an ignorant man trying to use a small amount of knowledge I have to move forward. So bear with me. So William James could easily be described as the philosopher of variety. And I think that it actually fits in well with a lot with what Ron Kokinis was saying. And so two Harvard voices kind of saying the same thing. They says essentially William James says, don't lament the many. If there's many different imaging formats, that's probably a good thing because it shows that we're creating something new. We're creating something that we didn't do before when the standard was defined. And so there's lots of different people that are creating images. There's lots of different ways to acquire images, uses of images, and formats of images. And so many is a good thing, and we shouldn't just be focused on the one, the controller of images, say radiology, the way to image people, say CT, the way to view something, or the way to store and communicate images. So when I wanted to know about, Daniel said everyone knows what an image is. I didn't know that was an obvious statement in itself. I went to Harry Barrett's tome, which someday I would like to read and would like to understand, which may be a retirement objective. But his Foundation of Image Science is a very interesting place to look at to describe what is an image and what are the different ways we can think of an image. And he and Kyle Myers have just lists of all the different ways that you can think of imaging. You can classify images by the kind of radiation or field that you're exploiting to generate the image. You can classify images by the property that is being imaged, what the imaging mechanism is, whether it's a direct or an indirect, MRI being an example of an indirect imaging technique. You can classify whether it's a passive versus an active imaging. Astronomy being a passive, nuclear medicine being an active form. And all these different types of images can be used and exploited in medical imaging. Of course, there's a variety of different questions that are asked about images. Maybe most importantly, are these images useful? And whenever you're thinking of useful, it's like, well, for what? For the patient? For the society, and there's competing demands. What's good for one may not be good for the other. And I think that what's always kind of framed my thinking on is, I think, a great article by Freiback and Thornberry that I guess goes back 20 years ago in medical decision making, the efficacy of diagnostic imaging, where it goes through technical efficacy, diagnostic efficacy, therapeutic efficacy, and then societal efficacy, and so on. And a lot of imaging research is focused on how much of something do you need, how much information is needed in the images to perform the diagnostic task you're placing before you. How much radiation do I need to use to get a good image? How strong of a magnetic field do I need in MR to answer something useful? Or another set of questions, is there a different, cheaper, or safer way to image this person than what the current standard is that we can be discovering? A big diagnostic imaging question is something really there? And the corollary is something really not there. And that's a really challenging question. We've talked about expert annotation, which has been brought up. You usually end up with multiple disagreeing readers. And so you just end up recruiting more and more annotators to come up with a majority vote or so forth. It's very costly, logistically difficult to obtain, and there's lots of questions about what can be done to facilitate getting that in a more feasible manner. Another big issue with radiology is pathology correlation. Daniel brought that up, but all he pointed to was a ring. And I'd say that pathology examination, currently practiced, is nearly useless for radiology correlation, because the pathologist in his task rarely does anything that provides you useful spatial information that allows you to map back to what was in that original diagnostic image. But that's what we really need, is we need to be able to correlate pathology to what we are seeing in the image. And so since pathology doesn't do it, various researchers have tried to do it themselves. One of these is Howard Jonas, who was at Pittsburgh for many years and now is the chair of neurosurgery at University of New Mexico, who did in-block resections of carotid. His carotid endarterectomies were all done in block. And for every one of the hundreds of carotid arteries he took out, he sectioned it, photographed it, so that he could have a good idea of what was actually in that patient versus what he saw in the images when he was making his decision to do surgery. That is very rare. And other people have tried to do similar things. Trent Hune at University of Washington has developed very elegant correlations between histology done specifically for their research projects in developing effective MRA techniques in the cervical carotid. But that is not something that is typically done. Radiology pathology certainly is a partnership. Sometimes you wonder if there needs to be as clear a distinction as there is. And pathology is learning that radiology can provide services to them, things such as virtual autopsies. There was a project at the University of Utah when I was getting my PhD that fetal autopsies or neonate autopsies are something that a lot of parents don't want to consent to. Very emotional time. They're very upset. But to do a quick whole body FSC or something that could reveal a majority of abnormalities that resulted in the death is something that they would consent to. The Army, or maybe I shouldn't say the Army, but the military also uses autopsies. All the bodies that come back through Dover Air Force Base are scanned in a CT scanner to try to get a good assessment of the cause of death and so forth. And spectroscopy is also something. And so I think it's fair to say that pathology could provide more value to radiology by a more systematic processing of specimens, a more spatially aware description of findings, and or a visual documentation with their reporting. Just to kind of comment on some informatics needs, taking, for example, MRI research. I always kind of find it funny that MR sequence is different depending on the vendor you buy from. If you're a Siemens, it's a turbo spin echo. If it's GE, it's fast spin echo. It's the same physical process underneath. And I don't know if things like Radlex or these other ontologies have come up with systematic descriptions of all the physical processes that lead to a different image. But there are so many physical processes in MR that can be exploited for image formation that it's probably a challenging and interesting domain to come up with a systematic description of it. I didn't meet, but I spoke with Richard Ward, who's a physicist at Oak Ridge National Laboratory, and he was working on the Virtual Soldier project, which became a virtual human project. And they started off with trying to come up with ontological descriptions of basic physical processes. And that could be applied to descriptions of MR or CT or other kinds of acquisitions. If you're an MR researcher, you're not probably very interested in the DICOM images of the MR study that are stored in the PACS system, because you've already thrown away a lot of information that is going to be of interest to you. What you really want is the case-based data, probably. And if you have the case-based data, there's a lot of research that could be facilitated, such as regrading techniques, looking at optimal trajectories, motion correction, constrained reconstruction, and so on. The challenge here is most of the case-based data is stored in proprietary formats that may not be shareable depending on the research agreements with the the vendors. But there are people that are trying to make this data accessible, and this idea is similar to what we're trying to do with IDASH. The International Society for Magnetic Resonance in Medicine has created what they call MRI Unbound. This is a project of Jim Pipe at the Barrow Neurological Institute in ASU, where they're trying to have a repository where people can put both simulated and real case-based data up there that researchers can access and develop techniques without having to have associations with radiology departments, and furthering the ability to do research in this topic. So I think that's a great example of things that are needed. And Jim unfortunately couldn't come. I invited him, and he really does like to know how he really should be doing this properly. Medical imaging is a multidisciplinary domain that has benefited from the rich contributions of physicists, mathematicians, engineers. The only electrical engineer to have a Nobel Prize is Hounsfield. Computer scientists, physicians are involved. Sometimes I don't like to admit that. Hopefully informaticists are making their contributions also. But sometimes the real value is in the synergy of all these people. And when people get working in isolation, sometimes funny things happen. And an example of this that I like to point to is from the ITK User's Guide. This is very old. But whoever wrote it, and there's a little bit of a comic hyperbole in their writing, but they're lamenting the fact that sometimes they're given anisotropic data sets to try to process. And they just think it's the ignorance of the radiologist that is giving them this data. And if the radiologist would only listen and learn and be properly educated and give them isotropic data sets, things would be so much better. But in reality, there's a lot of really good physical reasons, physics-based reasons, that an anisotropic data set is acquired. And I have lost track of who the researcher that said this, but I thought it was a great line. All good image processing starts with physics. And if anyone on this chain of medical imaging loses track of the whole kind of information source, we can lose our value. So I think one of the aims of informatics should be to help integrate the entire imaging process, from the physics of the acquisition, the mathematics of the reconstruction and post-processing, clinical interpretation, use, and essentially looking forward the social efficacy of the images that have been acquired. William Johnson at Arizona State, as an economist in the Department of Biomedical Informatics there, and says you can really never make any claims about the cost effectiveness of any medical technique because no one measures the downstream costs. And so we think of a CT scanner being cheaper than an MR, but now we have concerns about CT-induced cancer, that if you were really measuring all the subsequent costs, you may make much different decisions about what is the most cost-effective technology to be using. So just kind of in conclusion, medical imaging is a diverse enterprise, and what's so fascinating about it is there are just so many different physical phenomena that can be exploited to create images, and we should just be looking forward to all the great things that will be replacing CT and MR in the future, because it's such a rich domain. There's a lot of interesting research needs, and I think this has kind of been addressed before, that they're different from clinical needs, and so it'll be unique research structures, standards, and ontologies that would be needed. And really, to make the best use of medical imaging in the future, we need better cooperation with pathology. We need to be asking bigger questions, and I'm sure that to be able to make good on all this, informatics is going to have to be a key element in all this. So, thanks.